going to record correctly. So, all right, here, it says to write down the degree. If the degree is even or odd, you don't have to write it down. We're just going to call it out and talk about these together. And then it also wants to know what you think the degree is, what the number of that degree is, and whether the leading coefficient is positive or negative. So if you were not here the other day, here's your quick review, and maybe it'll make more sense as we go through all of this. But basically, because both ends of this, the left side and the right side, are pointing the same direction, I know this is an even degree function. And then, because the right side is pointing up, I know the leading coefficient is positive. Because both ends are going the same direction, again, this is another even. But because the right side is pointing down, I know the leading coefficient is negative. This one, the left side points down, the right side points up. Because they're going opposite directions, I know it is an odd function or an odd degree function. Because the right side points up, the leading coefficient is positive. This one, opposite directions again, so I know it's got to be odd. The right side points down, so that means the leading coefficient is negative. So, all right, here we go. For this one, is this an even degree or odd degree? Even. And it is even because both the left and the right point the same direction. Is the leading coefficient positive or negative? Positive. Now, what degree do you think it is? Second. Because what you're going to do is you're going to look at the turning points. I've only got one place where it turns around, and add one to it. Okay, so second degree, it's even, leading coefficient positive. For this one, is it odd or even?
Odd.
Odd, because left goes down, right goes up. What degree do you think it is? 3, because I've got one hill, one valley, so that's 2 turning points plus 1 is 3. The leading coefficient, is it positive or negative? Positive, and that's because the right side points up. Now, it asks how many real zeros does it have? We didn't talk about this in this chapter. We talked about it in chapter 4 with quadratics. Anybody remember what real zeros are? Okay. Zeros, solutions, roots, x-intercepts are all the same. So how many x-intercepts does this have? 3. Okay, so now, take a look. The degree for this one was 3. I should have 3 total roots, or 3 total zeros, 3 total solutions. Okay, since I have 3 real ones, I don't have any imaginary. Okay, all of my solutions are real. And then it asks about multiple zeros. We haven't talked about that at all yet, so I'm going to hold off on this until we get another couple questions down here. Okay, this one, is it odd or even? Even. What degree do you think it is? 4. Leading coefficient, positive or negative? Now, how many real zeros does it have? 2. I should have 4 total zeros. If 2 of them are real, what are the other 2? Imaginary. And then it asks about multiple zeros. Again, we're going to save that for another couple of questions. All right, odd or even? It is odd. What degree do you think it is? Third. And the leading coefficient?
Negative.
Multiple zeros we're going to come back to. Okay, odd or even? Odd. What degree? Did somebody say 6? I was going to say, if you said 6, is 6 an odd number? No, those two things have to match. So this one is a 5th degree. Is the leading coefficient positive or negative? Positive. Now this time it doesn't ask how many real zeros, but it asks what are the zeros.
-5, -4, -2, -1, and 1.
Very good. Okay. So how many of those did I list? 5, and I'm supposed to have 5 total, so we got them all there. And multiple zeros is coming up next. Alright, is this odd or even?
Odd.
It is odd. What degree do you think it is?
Fifth.
Fifth. Positive or negative?
Positive.
Positive. What are the zeros?
0, 1, and 3.
0, 1, 3. Good. So now, I only listed 3. How many am I supposed to have? 5. So, that might mean that I have some imaginary zeros. Not true for this one. What I want you to see for this is take a look at where it touches the x-axis at 0. Right there, you see, if I'm tracing the graph from the left, I get to 0, it hits 0, it bounces off and turns around. When it does that, that is a multiple 0. So technically, we should list 0 twice. The other place that it bounces off the x-axis is over here. As I'm continuing to trace, I get to 3, it bounces off, turns around, and goes the other direction. So 3 could be listed twice as well. So if I do 0, 0, 1, 3, and 3, that gets all 5. So now when it asks, are there any multiple zeros, the answer is yes, because the 0 was listed twice. It has a multiplicity of 2. 3 could be listed twice. It has a multiplicity of 2. Okay. So now this one, is it odd or even? Even. What degree do you think it is? 6. Positive or negative?
Negative.
Negative. Okay, what are the zeros?
0, 1, 2, 3.
Are there any multiple zeros?
Yes.
Where are they? 1 and 3, and they have a multiplicity of 2. Okay, as soon as we get finished with this, we're going to look at a couple that have like a multiplicity of 3, and then we'll relate this multiplicity of 2 to stuff we did in Chapter 4. Okay, last one. Is this odd or even?
Even.
Even. What degree do you think it is?
8.
8. Positive or negative?
Positive.
Positive. What are the zeros?
0, 1, 2, 3, 4.
Good. Do I have any multiple zeros this time?
Yes.
What are they?
1, 2.
1, 2, and 3, and they have a multiplicity of 2. Okay. Alright, so let me get my paper, and we're going to look at how it relates to what we did in Chapter 4. So do you remember back in Chapter 4, sometimes when we factored something, it ended up looking like this. So that when we solved it, set each of those equal to 0, I ended up with the same answer twice. Okay, in Chapter 4 we called that a double root. That's the same as having a multiplicity of 2. It's just new terminology. Okay, and when it was a double root like that, remember the only place that graph would touch the x-axis would be at -3, and you can see that it bounces off the x-axis there. It's just a new way of looking at it. So now, let's take a look at something that has a multiplicity of 3. And we talked earlier about a little bit of a wiggle in the graph. So here, if my graph comes to the x-axis and wiggles as it goes through the x-axis, that point right there is going to have a multiplicity of 3, or possibly a higher odd multiplicity. Okay? If it goes straight through, it's a multiplicity of 1. If it bounces off, it's 2. If it wiggles as it goes through, it's a 3. Pretty much in here, we're going to stick to single multiplicities or multiplicity of 2. You'll do more with this when you get to pre-cal, but I did want you to at least see it.